Hello everyone, it's Peter. Welcome you back. So in last class, we talked about a very simple introduction about collection framework with list and set. List is an ordered collection, and the set has no duplicates. So in this class, we want to move deeper for the set, especially the HashSet. So I list some topics we want to cover. The first one is the internal workflow of a HashSet. Now, to understand this, last time let's record the duplicates in HashSet. We talk about the a dot hashcode equal to b dot hashcode, and then a dot equals b. Okay. With this condition, we already have an example to prove that. Now I give another example. Come back here. I use class A. Okay. There's a value inside. There's a constructor. Int value start value equal to value. Now I override hash code. So in this hash code, I return a random number. Random dot next int. Say the random number is between 0 and 100. Random is API in Java, and it will create the next int means that it will create random number between 0 and 99, right? 100 is from 0 to 99. So I need to import java.util.start. So random is also under the java.util. Now equals. I give a very simple definition, just return true. So for whatever it compare with whatever elements is returned to true. Now let's talk about set. Set equals to new HashSet. Then I create element new a. Let's say 2. Okay. Now in the for loop, I add this object a for the same object of a for 100 times. Now I print out the size. Yeah. So you can guess what's the size. So based on our formula, we need to compare the hash code, but the hash code is a random number. So at most, the size is 100 because I add 100 times. 100 times. But because it's a random number, it could be duplicates with for the same A for twice. So I believe this size should be between 0 and 99. Let's run it. Hash code. Sorry. Hash code will return an int value. Missing return element. My class 21. Oh, this is return. Sorry, return. Now let's do execute. You can see 70. If I run it again, 63, right? As I said, it's between 0 and 99. So like this kind of hash code definition is not good at all, right? So hash code should return a fixed number. It cannot return a random number. Just make a test to prove that they will check the first condition. We check the first condition. So if I run 100 times, the hash code will run 100 times, and every time it has different hash code. maybe the same hash code or maybe different hash code, but the thing is that this object A is the same A, right? I didn't create more than one object. There's only one object of A. Right? Now I give another definition. Right? In hash code, I just return 100, return one number, and equals, I always return false. Then what happens? In this case, the same object A, if A compared with A itself, the hash code is the same, but equals is always false. Does that mean the size will be 100? You can guess what's the size. I will tell you the size is only 1. And you can run many times, it's always 1. Okay, so it means this formula does not work because A and A has the same hash code. If I change this to A and A equals A, this one is always false, right? If you compare itself, it's always false. So true and then false is false. So it's not duplicated. We add a new A again and again, but it's the same A. That's why here I need to modify this condition to A equals to B or A dot equals P. So we have to use this condition. This is a modified condition. That is, if the hash code is the same, then they won't call equals directly. They will compare their real reference first. If A equals to B is true for the all part, it won't go to the next part. So here, maybe I need to make up of the n and the all. Okay, so like expression 1 and then the expression 2 means what? If exp1 is true, is false, then return false. It won't go to exponential 2, expression 2. So we have two Boolean expression. If expression 1 is false, and then it won't go to the second expression. If expression 1 is true, then check expression 2. That's a double end. If we use all, means if expression 1 is true, because all means one of them is true, then it's true, then return true. If expression 1 is false, then check expression 2. Right? This is double all, just make up of the double end and double all. So in this logic, they have the same hash code, and in this expression, they first check A equal to B. If this is true, it means it's the same object. It won't go to the equals method. Okay, it will return true. Now, this is our guess. Now, what really happens in HashSet? So now I will give a explanation. Workflow in HashSet. Then step 1. When a HashSet object is created, it will create an array of bucket. Up to now, I think you should already know what is the count sort or what is bucket sort. That is, there's a bucket is not based on the comparison, so it has just a bucket. So each bucket has an index. So you can understand this HashSet as a hotel. And each bucket is a room. Each room has a number, like room 301, room 102, room 1110. This is the room number of each bucket. So when a HashSet object is created, when I create a HashSet, it means I create an array of bucket. Each bucket has an index. For example, I have an array of 10 elements. So then the bucket number is from 0 to 9. Bucket 0, bucket 1 until bucket 9. So suppose the initial size of set is 10. Okay, just we use another name. Actually, it's an array, but we use another name called bucket to help you understand what happens. Now, step 2. Let's say the object is let's say set is created. Then set dot add an object. Add an object of A. So when I add object of A, what happens? So then we do 3 things. First, it calculate a dot hash code. A dot hash code. So we know each object has a hash code. Say the hash code is x equals to say x is the hash code. Is the hash code. Okay. Second, use a hash function to map this hash code x to a bucket index. To a bucket index. That is, there's a say hash function, hash of x mapped to some bucket index. For example, suppose I have a 10 bucket. The bucket number is from 0 to 9. So an easy way is that I found the hash code, I do mod 10, mod the size. So for example, this is not real, this is not true, but I just give you an example. For example, I map x map to x mod 10. So this hash code mod 10, the remainder should be between 0 and 9. Then we get the bucket index. Now the third step, check whether the bucket is empty or not. So then there are two cases. Why I delete it? Sorry. I click some key and delete this one. Then I still make the first step. If the bucket so this is not good in Notepad. Let's come back to Notepad++ because then maybe a smaller size. Let's see, don't save. Okay, now let's write it again. The size is a little bit smaller. I don't know how to make it bigger. Make it a bigger size. I tried. Workflow of HashSet. Okay. So I already talked about. I don't repeat the first step. That is create a HashSet which create an array of buckets. Okay. Now let's say set dot add a. Then the first step is calculate a dot hash code. So let's say x equal to a dot hash code. The second way is map x to a bucket. So for example, x maps to through a hash function. A hash function is not hash code, just through a hash function. For example, x maps to x mod 10. I just mentioned that if the bucket, there are 10 buckets at the beginning, so the bucket number is from 0 to 9, so x is mapped to x mod 10, so this will get the bucket. So then the verify whether the corresponding bucket is occupied or empty. Okay, there are two cases. Case one, the bucket is empty. That's easy. Then save A to this bucket. So it's like A is a guest. The guest will live in this room. The room is empty, so that's easy. Then case two, the bucket is occupied by some other element. Say B. B is already occupied in this bucket. So then there is a conflict, hash conflict, called hash conflict. Hash conflict, what happens is then A will occupy this bucket and create a link to point to B. So it means, suppose I have a room, the room already have a B. Then after that, after A, let's say B is the guest. Then A comes to the same room or same bucket. Then A occupies the room, and then A has a link to the B. So it becomes at this bucket, it becomes a linked list. The newly added element A will be the root of the linked list and point to other elements of the linked list. Okay. So that's what happens in the HashSet. What happens in the HashSet. So then you need to understand what is a linked list. What is a linked list? Linked list is different from ArrayList. So here I just say linked list is not an API of the is not an API of Java. Java has an API of linked list, but the inside is a node. So this is a homework for you to do. So let me. Okay. Today we have a lab, so I will open the Eclipse. Yeah, let's go to the training projects. Yeah, I quickly show you what's inside. Yeah, so we'll import this one. Let's say property Java compiler. Oh, it's already here. Okay, that's fine. It's already there. This is lab. Here is one of your lab. Is my linked list. I just simulate the real linked list in Java API. So in the linked list, I use the generics. There's a node. Node is the element, hold the element, and there's another node with the next, point to the next. So we have root node, and then from the root node, we can point to the next node. So here I have some work for you to do. You can add element, you can get element, you can remove element, get with index, and there's a size. Yeah. And then you can return the size. Okay. If you want other private variables, you can add private variables. It's up to you. And then in the test, my linked list test. So I just add A, add B, and then the size is 2. Okay. And then get 0 is A, get 1 is B, and I remove A, then B will become the first one. So get 0 will be B. So this is the one I want you to do for the lab. I will give the lab assignment later on, but this is an example. So after you finish this, you understand what happens in the linked list. ArrayList is very easy. It's like a string is an array of characters, and the ArrayList is an array of some elements. Now let's come back. So this is the workflow of HashSet. Hopefully you can understand what happens in a HashSet. So this is extremely important for you to understand other structures. So this is very important. Now we finish up with the workflow of HashSet. Now let's come back to this collection framework. We already know the list and set. And in the list, we have ArrayList, vector, and linked list. So ArrayList and linked list we talk about. So we can compare their performance. Let's see. Performance between ArrayList, linked list, and HashSet. I just compare with the 3 of them. And here I give a table. So let's say ArrayList, linked list, HashSet. Okay. I use 3 different ways. One is insert, one is delete, and one is access. Access is random access. It's just read an element. So for ArrayList, the running time of insert is big O of n. Suppose I have an array of n elements. So I want to insert someone in the middle. So I have to make a shift from this element. So for example, I give an example of if it's an array. So for example, it's an array. Inside the array is an array equal to 1, 2, 3, 4, 5. Now I want to add 6 at index 2. That is at a position of 3. Then it will become 1, 2, 6, 3, 4, 5. Which means that the 3, 4, 5 will move to the right, will shift to the right by 1 unit. Okay, and then 6 will occupy this place. So if we add 6 at the top at the first index, it will take big O of n time. But the linked list is different. Linked list insert will take big O of 1 time. Okay. The reason is that in the linked list is 1, 0.2, 0.26, 0.3, 0.24, 0.25. Then I add 6 at index 2. So I don't have to make any shift. I just add 6 at 2.26 and 6.23. That is 1.2, then 0.26, then 0.23. So it will be this structure. It means that I only take between 2 and 3. I just change the pointer and change the pointer from 2 next to 6 and 6 next to 3. Then that's it. This becomes a linked list. Okay. So it means that it's big O one of time. I don't have to shift one by one. Okay. And HashSet, the insert is big O of 1. I already talked about the workflow of HashSet. It will calculate the new element's hash code and then directly go to the bucket. And then most of the time the bucket is empty, then I just add it. And delete is the same. So you can think about delete by yourself. This is a big O of 1. And access, ArrayList is the best. So because it's big O of 1. Because if I want to visit the second element, I just get index of 2. That's it. But the linked list is different. The linked list, you don't know what the position of the second element. You have to go from the first one, then point to the second one, from the third one. That's the index 2. Okay. So this one is big O of n. And HashSet is big O of 1. So if you want to access some element, again, you want to get the elements, these elements hash code and go to the bucket. Then you find this element. So the difference is in the list, you can have index, but the set doesn't have an index. The reason is the set is not ordered. So it doesn't make sense to get the third element to get the fourth element. It doesn't have this order. Based on this hash function inside the hash set, so it doesn't keep the order of the insertion element. So this is hash set. But looks like hash set is best, right? It's always all big O of 1. But the bad thing is that it may have overhead. The overhead means that it has redundant places. For example, if the set has 10 buckets, but I want to add 5 elements, there could be the conflict, right? So if I say, let's use this example. Like in this example, the hash code is returned to a fixed number. Then it means what? If I add 1 million elements for in this hash set, then all the elements they move to the same bucket because the hash code is the same. They use the same hash function, then the bucket is the same. So all the 1 million elements will move to the same bucket, right? To the same bucket, and then this hash set will reduce to a linked list. So here I will add it. If we override hash code to return a fixed number, then hash set will be reduced to a linked list, right? So because it's not, so if we want to design hash code, we want this hash code to be evenly distributed through all the buckets, so that it will use all the buckets very efficiently. But that may not be true if the hash function is not designed very good. So some bucket may be always empty, and some bucket may have conflicts and will become a small linked list. So this becomes the overhead of the hash set. Okay, so HashSet has overhead, but the ArrayList and the links doesn't have on this overhead. And then there's another thing is about the resizing issue. Resizing. So assume ArrayList has at the beginning has 10 elements. If you already add 10 elements and you want to add the 11th element, what can we do? So this array will be double sized, and then move the old array to the new array, and then you can get an array of 20 elements. So this is increase the resizing is 100% increase. Let me think about that array list. I just say yes or no. Then how to resize is another topic. This is yes. But linked list, we know we don't have initial spaces. It's just a node. So there's no resizing issue. You can always increase element without resizing. And the HashSet, yes, it also has resizing issue, but it won't go to 100%. For example, if you have a 10 bucket, you may only add 8 elements, then it will be rehash. So the rehash rate can be defined in constructor. By default, I think it's maybe 80%. I'm not sure. You can check the official document, but there's an initial rate. Like if you reach the 80% of the capacity in the hash set, then it will be rehashed. But you can also change this rehash rate. But for ArrayList, what's the resizing rate? That is, then we talk about the difference between ArrayList and the vector. We can make different things. Okay, let's do this. ArrayList and vector. So then one is the thread safe issue. ArrayList is not thread safe, and the vector is thread safe. So this is similar to the stream buffer and stream builder, and the resizing rate. ArrayList, I think, is increased by 50% if you want to resize, and the vector increased by 100%. It means at the beginning the ArrayList has size of 10, but after it reaches the size of 10, it wants to add 11th element, it will increase the size to 15, right? 50% increase, but the vector will be increased by 100%. For the other part, I think the two APIs, they are almost the same. Most of the time, I will use ArrayList because thread safe means if it's thread safe, it means the worst performance, and not thread safe means the better performance. Okay, this is a roughly comparison between ArrayList, LinkedList, HashSet, and vector. That's those APIs. Okay. And the map is a key value pairs. Hash map is corresponding to HashSet. Map has key value pairs. There's a key set to change a hash map to a hash set. Okay. So now let's go back to our slide. Then we talk about comparable and the comparator. We'll talk about map later. So let's talk about the comparable and the comparator. The two are interfaces. Comparable and the comparator are two interfaces for comparison, for the sorting. So now let me give you an example in the code. Let's go back to the Java. We go to API. Let's create a class. Let's say this class. Let me write an order. Let's say an item. So an item has ID. An item has a price. Okay. and the item has a int, let's say string name. Okay. This is the item. Okay. Now suppose I have a constructor to initialize the item. So you don't have to use get and setters to set the items. So it is item ID, item price. Actually, price can be double, but that makes things easy. And the name. Okay. This dot ID equal to ID. This dot price. This dot name equal to name. Okay. That's a very simple code. It's an item. Now I want to have several items. I want to compare them. So let's do the test. New class. Comparison test. Just this is to test comparable and comparator. Okay. What is comparable? So we know we have two items. How do we compare which item is bigger, which item is smaller? Right? So how do we compare that? So we can select the field. For example, we can sort this item by ID. ID 1, 2, 3, 4 is follow the increasing order. Or we can sort by price. Or we can sort it by name. Okay. Or we can combine the sorting. So if the name is the same, we compare the price, something like that. So I just make things easy, just to compare with one items, with one field. Let's compare with ID. Okay. So one way is to implement comparable. So this is a generic type. I can put the item inside and just compare with another item. So in the comparable, there's only one method called compare to. Compare to another item. So we just return. So because this is int, so int can return the greater than 0, less than 0, or equal to 0. Equal to 0 means it's the same item. Okay. Now I just use if else. If item dot let's say if price less than item dot price, right? Then return -1. Be careful, I don't use get price. The reason is it's a private method. This ID can be accessed within the class, right? Then else, if price equal to item dot price, then return 0. Then else, return 1. So this is normal comparison. So it's starting from the smallest one to the biggest one. This comparison. So with this compare to method, we can use sort algorithm. We can use sort method to sort the multiple items. Okay. Now let's start with the list of items, item list. So here in the unit 5, we can use annotation called before each, with setup initial method. Okay. So in JUnit, I think in unit 4 is before class. Here's another difference. So this is just a syntax difference. So you can say, oh, it's just before. Okay, it's just before setup. Okay. Here I can use before each and set up the item list. Okay, then item list equals to new array list. So item list dot add new item. Let's say ID is 3, price is let's say 50, and this is a book. Then item list dot add new item So is 1, so is 80. So for example, is a CD. Just give some dummy data if it's 2, like 25. So this is a movie. Now I just initialize the item list. Now the first one, the first test comparable. Okay. So we know at the beginning in the insertion order, the ID is 312, right? But in our item, item I use price. To compare it. Now the price is not in the in this order, so I can use collections dot sort the item list. After I make this sort, in the sort method, it will automatically to find the comparable compare to method. Each object in the list of each object in the sort method should implement comparable. So after this sorting, so the price will start with 25, right? So then I can use assertions dot assert equals 25. Item list dot get 0. The first element should have price of 25 dot get price. Others I don't have to check. To make things easy, I use static. I can run because I use lots of comparisons. Then this is assert equals. Then the second largest price is 50, right? Get 1. This is 50. Then the third one is 80. Get 2. So then I use comparable. Right. Yeah. If you don't sort, then that's not correct. Right. So, but it was 50, right? The first element is 50. But after I sorted, this sort inside the collections. Collection is API collections. So in the slides, I also mentioned about the collections API. There will be some other classes. We will go to the official document to go through those methods. They are all static methods, class level method. You don't have to create a new for this collections class. No. Let's come back to the code. So after sorting, so it sorts based on the price. Now next, I want to sort by the ID or by the book, by the name, because this name is already in the assertion order. Let's give another name. Like Apple is better, so I use this one. Still the movie. Let's use let's say toy. Okay, let's change it to this one. So it won't change anything. Okay, now in the real life, we want to get a sorting of a collection of objects. The object has lots of fields. We may need to sort based on different field. Now, comparable can only determine one field. Okay? But what if I want to sort by the name or sort by the ID? Okay? Now, I just use comparable. Test comparable. Okay, comparator. Sorry, I use a comparator. Comparator is also an interface. In the comparable, so the item can implement comparable interface and override one method called compare to one item. But comparable, comparator has one method called compare with two items. So this comparator, we can define a class like this. Let's say we can define class item comparator implements comparator. Then say item. So implements. Okay. So it adds the compare. Add anti method or compare item A, item B. Again, we can return what? A dot get name dot compare to B dot get name. That's it. See this? Because the string API also implements comparable. So we want to compare the name of two items. Then I just use the name dot compare to another name. So I don't have to like the int value. Just use the bigger than or equal to or less than to return different values. So this is compare. So then I can also collections dot sort item list, add a new item comparator. Okay. Now I use a comparator to implement comparator item comparator to implement comparator interface, and after that, so you can see the sort method has two overloaded methods. One is sort a list of items. The second is sort the items with comparator. In this case, the first list may not contain any comparable. I just add a comparator to help the sort method to compare the list of items. Okay. Now, next I don't use get price. I think it's get name. Okay. Now this time, if I use get name, the first one should be CD. Then the second one should be movie. Then the third one should be toy. Okay, based on the name, based on the string. Right. Okay. This is a comparator. Now, next I give a more advanced way to write this comparator. So we don't have to define a separate class called item comparator. We can run the sort method directly. So test. Let's give another way. Then here we use anonymous inner class. This is just a simple inner class. This I just use two. So it means I new comparator here. Inside the comparator, here is item. Okay. And I override, move the code inside. This is called anonymous inner class. And this way is more efficient. I don't have to write a separate class. I just a new interface. We know an interface is purely abstract. We talk about abstract class and interface. And we cannot new it. But we can use the abstract, we can use an anonymous inner class to new interface. And inside we use curly brace and override all those methods inside this interface. We can apply the same thing for abstract class. We mentioned about the abstract class is like a normal class, except it cannot be newed. But we can still use an anonymous inner class to new an abstract class. And inside the curly brace, we can override this abstract method. We can do the same thing for both abstract class and the interface. So this code is more efficient than, let's run this again. So we can run the whole test. See, yeah. I provide two different ways to use comparator, and you can see the benefit of a comparator is very flexible. So you can, based on what field you want to compare, to compare and sort, and I just add a comparator in the collections method. So this is about comparator and comparable. Okay. Now, next is iterator and enumeration. I think this one, I only need to know the iterator. And the next one is how to go through a collection, how to go through a map, how to go through a list. I think I will move to the next class. And in the next class, we have more time. I will talk about the lambda function in the in our collection framework. So we need to break into 3 sessions. Okay, I will stop here. Thank you. Oh, wait. One more thing is I still need to leave the assignment for you. This is a lab. This is a lab for this class and next class. And this is under this collection package. I will show you what's the lab you need to finish. The first one is is student class, and then you need to write, let's say, student test. So to override hashcode and equals to make the size equal to 4. Okay, this is test case. This is about student. So this is practice of how to write hashcode and equals. That's one thing. Second thing is about the queue and the stack. You know, queue is first in, last out, and the stack is first in. Sorry, queue is first in, first out, and the stack is first in, last out. So you need to go through the stack API of Java, and then I use the two stacks to implement the queue. Okay, I use my own queue. Okay, use push and pop, and here is the test case. This one you need to make a research of how to implement the queue using two stacks. Now, next one is my linked list. I already mentioned that. And next one is about the employee. Employee with ID, name, and salary, which is similar to our case. And then employee util will be sorted by name, sorted by salary, and convert to map. So how do you convert an employee to a map? Map is a string and integer value to convert to map. Here I have a string util test. Okay. And convert to map, and you can get the int value with a name and get int. So with a name and salary, name and salary. Okay. Then this is a test case. So that's all for in the student I have a enum type gender, and here is to help you understand what's enum. This is very simple. Okay, you know how to write it. That's it. That's all the lab. So you need to finish this lab. Okay, that's all. Thank you.